sorry for the introduction. In our project agenda, we have introduction, literature review, its background, and methodological work, research and discussion, and communication. As I quote, a transition to clean energy is about making an investment in our future. Further, we all know climate change is real, therefore, the need to incorporate renewable resources into the power system. In order to integrate resources, there is a requirement of balancing energy demand along with strengthening grid resilience and reliability. According to the International Energy Agency, the overall energy demand for South Asia has grown 80% since 2000, and Asia accounts for 80% of the world's foreign consumption. To achieve net zero carbon emission energy transition to renewable sources is very necessary. Our research on this project is mainly focused on these three portions. Number one, the current scenario of the power sector of several countries. Number two, main drivers and challenges that are going to affect the energy transition of South Asia. And number three, effective solutions to overcome these challenges. In our project objective, we have carried out SWOT analysis that is strength, weakness, opportunity, and threat, in which we have taken views from various experts of all sectors, accompanying from 7 countries. Thank you, and I hand over this podium to Mrs. Harshani, and she will continue the next year. Thank you.
Thank you, Shari. I'm Harshani from Sri Lanka. I will read from chapter 2. First one is our chapter is literature review. When it comes to the literature review, the most important thing is documental research. So when it comes to the documental research, guidelines for the effective research is vital. So these are the guidelines for the documental research. Effective one, defining clear research objective, identify relevant document across various sources, evaluate document quality, and organize data, and draw conclusions, and propose proper recommendations. And the other part of our research literature review is taking expert opinion. We have done 2 key components of expert opinion assessment and factors influencing confidence in expert opinion. Those are the factors and key components. And when it comes to the questionnaire, crafting the questionnaire is a crucial for success survey activities and rely on practical knowledge rather than theoretical foundation. Key steps for questionnaire design is determining sample questions, grading questions, testing, distribution, and data analysis. And SWOT is a strategic planning fundamental and offering structured approach to evaluate organization and sectors, and external analysis of the SWOT and identified the threats and opportunities, and the internal analysis uncovers the strengths and weaknesses. And the other part of our literature review is power system analysis. Power system analysis is crucial for sustainable energy transition, but evolving to meet challenges in energy transition and ensures the reliable electricity supply. And using of power system software is crucial for power system analysis. Key features of our power system software is system modeling, advanced applications, database management, renewable integration, and benefits are seamlessly integrated robust modeling with cutting-edge algorithms, and those are widely used in universities and research institutes for research purposes. Then the last part of our review is the mechanisms used for loss reduction, voltage regulation, improvement, and avoiding bottlenecks and overload management. When it comes to the transmission system, those are flexible AC transmission systems, capacitors, network reconfigurations, regulating transformers, and for the distribution system, we can introduce static buck compensators, network reconfiguration, distribution generation integration, voltage regulation devices, and active compensators. And also battery energy storage systems to heat sharing and voltage supply. And it could be used in both transmission and distribution systems. And chapter 3 is our methodological framework. And this is the overall framework of our project, that is the nutshell of our project. We have started with the documentary research. We have done a comprehensive documentary research for 7 countries, and out of that we have prepared a radar chart for all countries, and from the documentary research we have prepared a questionnaire for the expert opinion, and then from that questionnaire we have prepared a SWOT analysis. Then from the SWOT analysis we have done an expert opinion review. So from that we have got weaknesses and solutions. Out of that we have come into a conclusion what are the feasible technical solutions for these energy transition issues in South Asian countries. We have 3 actions as we specified before. First action was the documentary research to define countries. So we have prepared 24 common questions to prepare based on the literature survey done by each member of each country. So each member conducted a research survey from their home country, selecting 3 experts from transmission, distribution, and generation in power utilities using the comprehensive questionnaire. The other one was the national and regional SWOT. The methodology was collecting data from experts, and then we have conducted a SWOT analysis for individual country. Then we have compiled it to one SWOT for region. The outcome was understanding energy sector dynamics, identifying strengths, weaknesses, opportunities, threats of some countries, and basic strategies and recommendations. The last part of our action 3 is computer-based simulation to access the most promising solutions. So we have the research team utilized PSST and Excellence Power Factory software renowned for power system analysis software for researchers. So the representative test system of South Asian region countries was deployed considering primary and secondary system of transmission and distribution voltages. Realistic data for the publicly available sources was incorporated, including 24-hour load profile for distribution substation. And for the integration of low carbon technologies, we have included PV power plants and battery energy storage were integrated into the test system to address the energy transition challenges. For the simulation methodology, we have used quasi-dynamic simulation to conduct 24-hour period evaluation to perform proposed technologies. We have used Simon for this. Focus was to address voltage profile, active power losses, and overloading, crucial issues identified in energy transition effect. And the whole objective was to research aims to offer technically sound solutions to energy transition challenges in some countries through leveraging digital simulation and analysis techniques. For the chapter 4, I will hand over to my colleague Natasha. Over to you.
Thank you, Harshani and AI team to express my research project in front of you. Thank you. Here we have go to the radar plot. You have seen we have generated a radar plot of the South Asian countries. We have set margins, set criteria. 0% is the minimum requirement of the South Asian countries, and 100% required. The maximum requirement is very important issue. So in this plot, we have identified the common challenges, and these challenges go to the transition in energy sectors. Okay. Here you can see the maximum countries have infrastructure challenges. So we have returned to the infrastructure challenges, advancement in our research. Also, sir, it has climate change impacts, environmental and social concern, also regularity and policy issues, energy access, affordability and reliability and resilience. Leveling of all the countries here, it can be discussed, but having time to describe all the radar plot in such a time. Thank you. The next slide is SWOT analysis. This SWOT is based on expert opinion, which we are collected by questionnaire. This is the final conclusion of SWOT of all 7 countries. The strength which we observed of SAARC countries, the investment in renewable energy infrastructure, potential for resource sharing and technology transfer. And the weakness we have observed are the aging infrastructure in generation and distribution sectors. Transmission and distribution challenges include network losses, reactive power issues, and voltage fluctuation. And what we have observed in opportunities of SAARC countries, the market have been reformed and incentive to promote clean energy. And policy alignment among neighboring countries also. Threats which they are bother us, that is the renewable energy sources can lead to grid instability, also the limited energy storage solutions. The next slide. This is our model system. Now I will explain. This test model is created to reduce and modify, simplify and model of SAARC countries, which we have tried to replicate of SAARC countries. This test model comprises 33 buses system, which have 15 load buses, which comprises 608 megawatt and 396 MVR loaded. And there are 3 synchronous machines, which are generating 634 MVA capacity. Initially, test model was prepared in power system simulation by Siemens. Then it was exported in by Rizna power factory. This graph showing the color diagram. The color diagram showing the loaded area, the red zone the loaded, heavily loaded area, and the other color is lightly loaded. Next. Here you can see the 6 graph, the plane base case, and in plane base case, we have only inserted the information from the South Asian, which we have collected information from South Asian countries, and we plot the some scenario. But you can see here some problem and voltage fluctuation. The first case is voltage profile, and then second green bar is loading profile of each buses. And the second case is, you can see we have fixed some fixed capacitor through the reactive power compensation. Here we have improved some voltage profile. And in third case, we have also done the reactive power compensation with step changing position of transformer. So it also reduced the maximum limit. In second case, the lower limit is adjustable, but the upper limit is higher in the limited area. So it is now in from the 3 cases, we have took the case number 3 for further simulation for our study based projects. Then next. This is the load profile of all 3 cases. This is the load. You can see from bus voltage per unit of each bus. The red one shows that these are heavily loaded, which are not in a limit cases. Voltage profile is our out of limit case. But in case 2, we have done some reactive power compensation. They are improved now. The red bar are less than in first one case. And in third case, I have been so much improved. Now it has reduced and it is now at adjusted limit position of voltage profile. The second bar is cube case of bar. This is the loading percentage of each buses. Red bus one is showing the heavily loaded buses, which is a transmission line of 500 kV in 220 kV system. One next, please. This is our case model. We have we have generated first in PSSC, and first we have checking the compensation. After the power compensation and tap changing of transformer, let's do in the PV injection in the power of every distribution power transformer. So you can see in the next slide the voltage profile and our power demand have reduced. This is the voltage, this is the power demand of every hour of every bus. Red one is showing the high profile demand, because the 220 kV and 500 kV have highly loaded, so its demand is high, and the other loaded behavior. Each bus is loaded out for every hour. This is the criteria. This is our loading behavior of every hour we have taken from the modeling system. In bar chart, in chart, you can see the first chart is the voltage profile of each buses. The bus number 11021 and the 1020. 1101 is highly fluctuation in voltage profile. It's a low end limit, and the bus number 1020 also have a low voltage profile. So, and also bus number 10 have a over voltage. And the second graph is the line loading of each buses, and the third graph is tap positioning of the transformer of every hour. This is we are showing just information, our situation, our system, how to behave in a normal manner. Then we have done PV injection. After the PV injection, we have seen a lot of power demand has been reduced, and also its impact on the power losses reduction. We have seen and observed from the first slide and in this slide we have reduced 15% of the power losses reduces. Our test model is a radial network except the high voltage side. Here we have created for at bus number 202. Pointing the 202 bus number kindly. So everybody will show the bus number which one is 202. Here we have created for at bus number 202 which one is line out of test network. So the stress level is increased on the bus number 2. It creates congestion on the system. But bus number 203 and 204 already is overloaded. So we use the best location to insert the battery energy storage system at bus number 202. So we have installed here at bus number 202 battery energy storage system, and the total capacity of battery is 900 megawatt hour. You can see by graph, small graph, the load demand was supplied by battery energy storage system for 6 hours. The battery energy storage system advantages, it improves the grid reliability and peak shaving also, and also store the excess amount of energy and reduce the grid congestion also. Thank you, and over to Ms. Komal for the conclusion part. Thank you, Natasha. So coming to the conclusion part, we have found that based on the SWOT analysis, South Asia countries have vast potential for renewable energy, with countries like Bhutan and India leading in hydroelectric power population. Countries like India had already set the target of achieving 50% of the installed capacity with non-fossil fuels by the year 2030. Coming to the conclusion from the simulation outcomes, it can be seen that integrating the distributed PV with battery energy storage has enhanced the system stability. Along with the usage of battery energy storage with the injection of active power, the battery energy storage has also helped in the transmission line loading. Coming to the implications of this study, integrating PVs with batteries have optimized the energy storage systems, enhancing the system resilience and facilitate the energy transition. Regarding the limitations of the study, I would just like to say that we have considered steady state condition, and our studies are primarily focused on voltage improvement and active power loss reduction. Now, the recommendation network would be advanced control strategies are very much required for both normal operation and contingency scenarios. Dynamic model and quasi-dynamic modeling are also needed to capture the transient behavior of renewable energy resources. Climate change, natural disasters, geopolitical risks are required to be considered for making the system resilient. In order to maximize the contribution to energy mix, smart placement of our resources are required to be studied. Further, at the end, I would just like to conclude that regarding the cross-border collaboration, hope the initiative of One Sun, One World, One Grid gets successfully implemented in the near future. That's all from Group 1.